All right, so right now we're going to be going over topic 2, lesson 2 activity, and I'm going to be showing you how we write what we call translation functions and how we can actually do the operation that the translation function describes. Okay, so on this assignment, in the first practice, it says to write a function to describe each translation. Each solid figure is a pre-image and each dashed figure is an image. Okay, so if you remember from the previous lesson, a translation is essentially just us taking a figure, let's say a triangle, and sliding it in some direction. Okay, so let's say we took our original triangle here, which we can call pre-image, right? Pre-image meaning the before image, before the transformation takes place. So let's say we take our pre-image and we slide it to the right so that we get some new image, right? Which we will call I for image, right? And let's say we slid that object to the right some distance, okay, which we can describe with a line segment, right? And that distance, that line segment, we will call AB, okay? So that we've slid this triangle the distance and direction of AB. Okay, so if we have a transformation like that, we can actually describe it with a function. Okay, so let's say we have some function, capital T, T for translation, and our function takes some input, any shape we want, any shape that's out in space. You know, we have a rectangle over here, we can use that rectangle. But let's just say we're going to describe this transformation in particular. So we would say triangle, right? Because we had a triangle. So I would write out triangle. And that's going to look very disgusting. Um, and we translated this triangle, the distance and direction of AB, right? So our subscript would be AB. Okay, so this function tells us what we're translating, and then it tells us in what distance and what direction we're translating it. Okay, every translation function is going to have this subscript down here that is associated with some line segment. Okay, this one is associated with AB, but as we'll see down here, these transformation functions that we'll be writing will be associated with a line segment PQ, or down here, another line segment QP, right? And so that's something that you'll see as you go throughout this assignment. But in any case, so this function is basically describing this transformation. And what we get out of this function is essentially another triangle, but it's the new triangle, right? It's the transformed triangle. It's this triangle. And so we're going to call that triangle prime. The prime meaning new. It's this little apostrophe up the top. So this refers to this triangle, right? And this, our input, refers to this triangle. Okay, and so you might be wondering, well, what's the point of this function, right? Well, this function, functions of this type are frequently used in programming, in web design and game animations, where they'll want to, move around some object, some player, and they'll have this function which takes in, some shape and some distance and direction, and when you call that function and you put in your shape, it can translate a bunch of things in the same way. Okay, so that's how that a function like this would be relevant. So anyways, we're going to go ahead and practice writing these functions. So down here, it says each solid figure is our pre-image, right? So we can call this our pre-image, put a P for pre-image, and this dash figure is our image. Okay, and as we've said before, the pre-image comes first and the image comes after. Okay, so if you notice, right, and I'm going to go ahead and take out the ruler in order to show you this. So if we, let's say, take this, right, and we draw a line here, the same distance as AB, Okay, and that was pretty horrible. But so we got that line here, right? And let's say we move this line. You'll notice that this line, if you put it at the vertex of this parallelogram, the pre-image of the parallelogram, you'll see that it matches up exactly with the point over here on the image. So this parallelogram has been translated the distance and direction of line segment AB. Okay, so we can use that to write our translation function. So the way we would write that is, say, we would write, okay, let's get the text box here. Okay, yeah, so we'd write capital T and then capital T and subscript. If I can actually figure out how to do a subscript. Okay, that's obviously not working. All right, bear with me. This is a lot more difficult than it seems. Okay, all right, bear with me. Okay, capital T, and I want to turn that into a subscript. Would you let me do that, por favor? Okay, well, just imagine this is a subscript, okay? Actually, let's just write out with the pen tool. Stop trying to be all fancy. All right, so we'd say capital T for our translation function, right? T for translation. And then since it's translated in the distance and direction of AB, we'd put A, B, right? AB. So this is in the distance and direction of AB. We are translating, and this is a parallelogram, so we're going to put para, short for parallelogram. So we're translating this parallelogram, the distance and direction of AB, and we get out para prime. Prime for new. It's the apostrophe, right? So we've just written out the translation function that describes this operation. And now we can replace para with any sort of object, and we can get that same translation, right, in the distance and direction of AB. And so essentially that's what you're going to be doing for the rest of these three problems. Except this subscript is likely to change and this input is likely to change. Here you have a trapezoid. Here you have a hexagon. Here you have a triangle. So would it be parallelogram? It would be the name of those shapes. And the subscript is also going to change. Here, this is your pre-image. This is your image. So you're going from B to A. So your translation subscript will not be AB. It would be B to A, right? Because you're going in the opposite direction. Same thing with this one, right? It's not going to no longer be A or B or B or A. It's going to be some order of P and Q, and I'll let you figure that out for yourselves. Okay, so now that we got that settled, let's move on to question 2. Right, and that translation function would be your answer for this question, by the way. Okay, so let's move on to question 2. So here they give us the translation function, right? And we read this as translate the rectangle, the distance and direction of AB in order to get rectangle prime. Okay, so let's go ahead and do that. Like I said, we're translating each of these points, the distance and direction of AB. So let's go ahead and measure out what our AB is. Okay, let's line this up. Okay, so now we got a parallel right there to the 2 points. So we're just going to draw our line as best as we can. Okay, so now we got our line here. So now we can copy our line, if Cami lets me do this. Okay, Cami does not let me do this. Okay, let me see. Can I copy this? Okay, well, Cami's not going to let me copy that. But essentially, we're going to get these lines, right? And we can draw multiple of these. So, um, okay, it's very irritating. It really should just let me copy it. Okay, let's just draw a couple of these so that we have them to move around. Okay, so let's go. So we're going to draw a line here. Okay, and then let's draw one parallel to that. Okay, and let's draw one parallel to that. So now we have three lines that we can use. And you're just going to be doing this roughly. Here I'm trying to show you exactly um, what's happening. But when you do this, you're just going to kind of eyeball it, or you could actually pull out a paper and mark down this distance and try to get as close to parallel as possible to AB. But here I just want to show you exactly what you're going to be, you're trying to aim to achieve. So we're going to place each of these lines on the vertex of this rectangle that we're trying to translate. And then we're going to go ahead and draw in our new translated rectangle, or in other words, rectangle prime, right? So now we can connect these translated points, and by doing so, we should get our new rectangle prime. So there we go. We've translated this rectangle into rectangle prime in the distance and direction of AB. Okay, and then you're just going to do something similar for, so this would be your answer for 2A, and you're just going to do something similar for B, C, and D, right? This one's saying to translate the triangle in the distance and direction of L prime M. So L prime to M. Ignore the L, that's just trying to confuse you. Here is trying to translate the trapezoid, the distance and direction of BA, okay, so B to A. And you're just going to be drawing lines that same distance from each vertex and parallel to that line, okay, so that you get lines rating out, similar to how we did here. Okay, same thing here. Translate the parallelogram, the distance and direction of L prime to M. Okay, so you're going to go to each vertex and translate it the distance and direction of L prime M. Okay, so good luck with that. I hope that made sense.